Welcome, this is Paweł from Coding Jam Session. Welcome to another episode of our live coding series. So today, once again, we're gonna dive into the advent of code for the year 2023, and we've got a day 4 ahead of us. So let's jump in straight to the story. Quickly go through and try to solve it as quick as possible. Right, let's go. The gondola takes you up. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of New Island and lurches into the station. As you exit the gondola, the first thing you notice is that the air in here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello! The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have. Though this is an island after all. I bet the gardener would know. He's on a different island though. The small kind, surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat. And you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what they want. Okay, so you're gonna be solving the scratch cards. Lovely. The elf leads you over to the pile of colorful cards. There, you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers, separated by a vertical bar, a list of winning numbers and a list of numbers you have. You organize the information to a table, which is our puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of the card. Okay, so we're basically we've got 2 arrays, and what we need to do is find the common numbers. Not even the common numbers, but the amount of common numbers. Quite easy. In the above example, card 1 has 5 winning numbers and 8 numbers you have. Of the numbers you have, 4 of them are winning numbers. So there's 4 common numbers. That means one card 1 is worth 8 points. 8 because 1 times 2 times 2 times 2. Okay, yeah, that's 8. So we've got 2 to the power of 4 minus 1. Okay. That's fine. So take a seat. How many points are they worth in total? Okay. So we basically iterate. It's very easy. Iterate through all the cards, find how many common numbers each card has, and apply the equation which is 2 to the power of common numbers minus 1. And just sum up for every card. Very, very easy. We should get this one sorted quite quickly. So let's dive in straight. Let's get our test input. Okay, wait, let me just put this on the side so you can actually have a better look of what I'm gonna be coding. Okay, so we've got a test input. Let's get our puzzle input. There we go. Lovely, and let's dive in straight to coding. So I've just set up the basic file like we did with the previous days. Just did some imports, a file name variable for our input. We're gonna start with a test input file, though we've got 2 files. two text files, one for the test input, one for regular input, so you can easily change it via variable. And this is just the performance that's gonna show us how quickly our code is running. That's it. So let's declare the solve part one function and invoke it here. There we go. And let's start with parsing the data. Okay, so let the data is a read file name to string, and let's just split it by rows. Right, my keyboard. 1 second, let me change the keyboard. There we go. And split it by rows. Okay, let's console log our data right away so we can see how is the parsing process going. So at the moment we've got a right, so at the moment we've got an array with cards. Let me just make it slightly bigger for you. Array of cards, each card is in a row, and that's a string. So we need to parse each of those strings, get rid of the first part, and our index is gonna be the number of a card, and we need two elements, the left and the right side, and those are gonna be the arrays. Okay, easy peasy, no problem. Let's go. So let's map through the rows. And let's return for each row. Let's split it at the beginning by, let's get rid of the first part. So split it by semicolon and space. And let's get the first element out of that. So there we go. And that we're going to split by a bar with two spaces. There we go. So we've got two elements, and those two we need to split by space and parse to integers, right? Right. Okay. Then in that case, let's go. So, so this element is an array with two elements. So let's map through this. Let's map through our row elements in our row, and we wanna split them by space. And now, there we go. So this is the left and the right. Each scratch card is having one array with the left numbers, one with right. There is some empty strings, and that's probably because there were double spaces like here or something. So we're gonna get rid of this, but first let's parse everything to integer. So let's map through those elements, and we're gonna return the parse int, and after that we've got not a number, so we can simply use a filter method and and leave only the elements that actually are the numbers, like so. And there we go. So we've got our data parsed. So we've got each card is an array with two elements, the left side and the right side, and both of those sides are simply the numbers. So we've got our data parsed. Easy peasy. All we gotta do now, let's try to be, oh yeah, we've got the solve function already here. That's fine. So let's try to be quick. We are gonna go through all the rows, and we're gonna go through all the rows, and we're going to sum whatever the score for each card is. So we're iterating through the cards and summing up the scores. That's fine. So in that case, we can simply use a we can simply use a reduce method. So because we're getting a sum, so we've got our accumulator in the row and a starting number of 0. That's fine, and each row is having left side and right part, and that's in an array, so we can use our destructuring thingy, so you can destructure the left and the right array from our row. 1, 2, 3, like so. There we go, and we need to find the common numbers for those two arrays, not the common numbers. We need to find the amount of common numbers. So we're once again gonna iterate through left side, and for each element that is in the right side as well, we're gonna check if the element is in the right side, and if it is, then we're gonna just +1 our counter, whatever. So we can use the reduce method again. For the left side, reduce, and go once again, like so. It's maybe, I don't know, call it a number because it is a number, whatever. And we're simply going to check if the right array includes our number. So if the number that we're iterating through is in both arrays, we're gonna increase our counter, and if it is not, we're simply gonna return our current counter. And after we've got those numbers, we need to, after we've got the number of common numbers, so let's put it into variables, call it numbers. So after we've got the numbers, we then need to check, we're simply gonna, we need to return our equation. And our equation is, okay, we're having a reduce function, so we're increasing accumulator, and equation was 1 times 2 times 2 times 2 times 2. So first is 1, and then we're going multiplying everything by 2, so it's 2 to the power of numbers minus 1. So that's gonna be math.power 2 to the power of numbers minus 1, and that is going to be our solution already. Let's have a look. We need to console log that. So wait, what? Why am I getting nothing? Oh, we need to return something. We're not returning anything, so we need to return this sum. Okay, yeah, that's fine. But we've got a strange number, so something is definitely not correct. So let's have a look. We are getting our numbers if we're getting, okay, this is fine. And so we've got a reduce function, and if okay, because we're not checking for the numbers, and numbers there can be 0 common numbers, so we didn't in case a card didn't, we didn't hit the winning numbers, and in this case this is gonna give us 2 to the power of minus 1, which is just bad. So we need to get a if statement and check if our numbers actually have value, and if they don't, we're simply gonna return the current sum. And it's still not correct. Something is still wrong. So let me just think. Oh, we didn't get any starting number for this, so that's another thing. And there we go, 13. And let's have a look. Let me show you. So the test input result is 13 indeed. That's great. So let's change our file to regular input. Bam, and let's see if our solution is correct. It's 27845, and you can see execution time is 3 milliseconds. It's quick, no problems. Let's go 27845. Bam, submit. And we got a gold star. Lovely. Part 1 was nice and quick. Hopefully we can solve the second part as quick and efficient as the first part. So let's go and solve 2. Declare the function. This time we're going to solve 2. And let's read through the part 2. Okay, just as you're about to report your findings to the elf, one of you... Oh, wait, let me just get this so you can... Oh, 1 second. Ai, sacrebleu, un momento. There we go. So you can actually see what I'm reading. Okay. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There is no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have. Specifically, if you win copies of the scratch cards below, the winning card equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. Okay. Copies of scratch cards are scored like normal scratch cards. Okay, so they can generate more copies and have the same card number. Okay. As the card number they copied. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. Cards 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table, so that's fine. So you at least know that if there's like a last card, it's not gonna have any winning numbers because it cannot go past the end of the table, so that is a good thing. So we've got a different example. So card 1 has 4 matching numbers, so in 1 copy each of the next 4 cards, 2, 3, 4, 5. The original card 2 has 2 matching numbers, so in copy of... and so on. So we're accumulating the copies, and once all of the original sent copies have been processed, we end up with 1 instance of card 1. In total, you have a 30 scratch cards. Okay. So what do we need to calculate? Process all of the original and copied scratch cards until no more scratch cards are won, including the original set of scratch cards. How many total scratch cards do you end up with? Okay, so we need to calculate all the scratch cards, basically. And the matching numbers we get from each card is generating more scratch cards for us. So let's say we've got those 6 starting scratch cards. If we get 5 matching numbers here, then we get another copy of each of these cards. So we've got two cards number 2, 2 cards number 3, and so on and so on. And for each of those, we need to check for the matching numbers, and we're gonna get more of the cards again and again, and we need to add the number of all the cards and copies all together. Okay. So first solution that comes to my mind is a recursive function that's gonna be invoked for each card, and then for each copies that this card generates, and so on and so on. But the only problem is let me move this on the side. The only problem is that our input file is having 215 rows, and this is the recursive function going through all those cards, and you can have as much as 10 matching numbers for each card, and then for each copy, and this multiplication, this is recursive function would be a very long computation. So we need to figure out a different solution. Now, so let's have a think. If we go from the beginning, we need a recursive function for each of the copies. But we know that, yeah, okay, I remember similar task in the previous years. There's been something very similar. So the solution should be the other way around, because going straight from the beginning, we need to use the recursive function, and it's a long computation. But if we go from the end, this card, there's only gonna be one copy. We know that this card has no winning numbers, so the score for this card would be 1, because we're counting only this card, and we know that it does not generate any more numbers because it's the last card. The card 5 can generate itself plus maybe a card 6. If it's got one matching number, it can generate card 6 and itself, so it can have a score of 2. And if we go from the end to the beginning and keep the total score for each of the cards, so for example this one, if it has 2 winning numbers, so its score is going to be this card plus the score of card 5, which is 2, plus the score of card 6, which is 1. So that would be 3 plus this, so it would have a score number of 4. And what we can do is simply go through the end, from the end to the top, and keep the total score number for each cards. And that way we do not need to be doing this many computation, because we simply keep the big score for each card, and that's it. It should be much easier, because even if it's like, for example, here, and it generates like, I don't know, 5 copies, and all those copies generate copies, and so on and so on. To check everything underneath, it's a lot of computation. But if we go to the top, we already calculated the score for this card and score for this card. We keep the track of those scores. So if this generates, for example, 2 matching numbers, we've got those 2 scores. It can be a big number, it doesn't matter, because we don't need to do computation, we just add up those 2 big numbers plus this card. So we're simply keeping track of the sums in an array, and that's just using the memory to actually have efficient computation. Yeah, that's fine. Okay, I think I know what we need to do. So let's try and code this. Okay, actually, to make our life a little bit easier, because I'm not sure what exactly we're gonna type in later, let's get a function that's gonna generate the matching numbers for each card. So we've got this out of our way, and it's not gonna mess up. We're gonna keep the code slightly neater. So it's the same way that we did it in the previous part. So we're gonna extract the left and right array from our cards by destructuring with the array destructuring, and yeah, so so we're simply gonna map through the left array with the reduce function. Okay, starting with a value of 0. Oh wait, that's something. something not good, and we're simply checking if the right includes a element, then we're returning the increased accumulator, and if it doesn't, pardonnez-moi, and if it doesn't, I don't need else, we can simply return accumulator. Okay, so we've got our function. It's the same code as we did in here. So we've got our function that is getting the matching numbers, so we can simply invoke this when we need. And how we're gonna do? So we need to loop from the end of an array. So your starting point is gonna be the last element. So instead of using the rubbish for loop, let's just reverse an array, and then we use our for each, and we're gonna loop through through all those elements. We need a variable because we said we're gonna keep a track of the total sum for each element, starting from the last element. For each element we're keeping a total sum, so we need a array, the temp array, that's gonna keep this track for us, and we're going to do it for each row. Okay, and okay, so we're starting with the last element, so we actually need an index here as well. And let's just see that if we've got the last element, so if our index last, which is in reverse array the first element, so if index is equal to 0, we're simply gonna push a what? We're simply gonna push 1. 1 second. Pressed something. Right, so if we've got our first element, then we're gonna push 1, and then with every other card, we're going to have to find the matching numbers, and for each matching numbers, iterate through. Okay, so let me open up an input. So we're keeping track of actually, let me type in a comment so I explain, because I know what I'm gonna do. Let me just show that to you. So we're gonna have a array that is card 1, okay, card 1, card 2, card 3, card 4, and so on. Comment it out. Okay, so this is gonna be our the temporary array that we're keeping, and this card 1 is simply gonna be a total sum that we keep track for each card. Yeah, so it's not gonna be the cards, but it's gonna be different numbers with sums that we keep track of. First card is having the sum 1. Every other card is gonna have a bigger and bigger total score, maybe not a sum, total score that we keep track. So when after we move from the first to the next element and so on, what we need to do is find the matching numbers for this element. This one is gonna be 1, so but let's say we go further, because this is 1, but let's say here, and we've got 2 matching numbers, so we need to extract those 2 elements from the array. So we moved here, but our array that keeps the track of the scores has all those 3 elements, but if it's got 2 matching numbers, we want to extract only those 2 elements. So what we can do is, and okay, when we extract those 2, we simply need to iterate through those elements and sum up those scores and add them together plus 1, and that's going to be a score of this one. So for extracting these elements, we can simply slice an array, because that's going to return a portion of an array, and it's not going to modify whatever we keep the track of. So I think we know what we're gonna do. So we will definitely, so we're pushing something to that temporary array anyway. We're pushing a sum. We're pushing a sum of what? We're pushing a sum of elements from this slice that we need. So we are gonna slice the portion of an array, slice something, and then after we slice for something, we're going to iterate and sum up those things. So we're gonna use the redoes afterwards. Okay, so we need to slice for something, and then this one returns a copy of the slice, but doesn't modify the array. So we're simply iterating through the slice, and we're gonna sum up those score numbers that we keep track of. So reduce function is simply gonna return the sum. So accumulator plus an element, because an element is the score. So this array is keeping the scores for each card. Element is a score. So this is the sum, and we simply need indexes for our slice method. And the indexes for the slice method, let me quickly think. Because we're going, let me just have a look at this input. So for this one, if it's 2, we need index 4. No, no, but we've got it reversed. 0, 1, 2, 3. So this is 3, and we need index 2 and 1, so we need array 1, 2. For 2, so we need to add 2 minus the 0, 1, 2, 3. So we need a 3 minus the matching numbers, which is 2. So 3 minus 2 is gonna be 1. So it's gonna be this index. And this is gonna be 3 minus 1, yeah? Okay. 3, no, not 3 minus 1, because it skips the last index, so it's gonna be actually the same index. Okay, so the first one is simply gonna be, we've got the index, so it's gonna be index of an element minus the matching numbers that we found. So we've got our get matching numbers function that we're going to invoke for each row. And so that's the first index, and the last index is I, because remember the slice method, when you've got index, for example, 0 and 2 in here, then it's gonna return array with indexes 0 and 1, not 0, 1, 2, but 0 and 1. So that's why we're gonna leave this one like it is. And actually, let me think if it's correct. So we're summing up all those. So for this input at the moment, like for this card, if it's 4 and 5, we're summing up those two, but we need a +1 for this card as well. So +1, we can simply start the accumulator with 1 instead of 0. So we've got +1 for each card that we're going through. And after we've got this, after we've got this done, let me quickly think. Is that it? No, that's not it. Okay. Because at the moment we've got array with all the scores. All the scores that we keep for each card, but we need to sum up all those scores. So in order to do that, we simply need to iterate for an array and sum up the scores once again. So that's why we're using the reduce function, and we're simply returning accumulator plus element, and the initial value is 0. Okay, actually it looks fine. I'm gonna say it looks fine. We're using a lot of reduce function. It's not very intuitive. It's probably the most difficult function in JavaScript, but I tell you what, the moment I've started doing the advance of code in like 21 and 22 is I was trying to utilize as many different array methods as possible just to keep code, shorter, cleaner, neater, and just to get yourself along with those functions, because it's actually making the life much easier once you practice those. So I think advent of code is a good thing to practice this kind of array methods. But anyways, I'm going off topic. We need to press BAM and see let's go and change the test input and see if our result for the test input is correct. Test input, it's 30, and just so you can see, it is actually 30 that we're looking for. So hopefully the solution is correct. Let's just try it on a regular input. And let's see, and look, it's 3 milliseconds. I'm 100% certain that if we went for a recursive function solution going from the beginning to the end of an array, instead of going from the end to the beginning, we would have at least a few seconds, if not longer than that, of computation. That's 100%. I'm 100% sure about that. Okay, let's have a look if the solution is correct. 9496801. Boom. And we get a gold star. Lovely. We've solved the advent of code for the day 4. And I think it was quicker than before. Slightly quicker. Well, I'm fresh and focused today. So that's a good thing. Right, just to sum up quickly what we did. So with the part 1, we've had to simply iterate through all those scratch cards and get the score for each card and sum up the scores. It was very, very easy. Getting the scores was simply finding the common numbers in those two arrays. So if it was just 2 numbers, it was 1 times 2 and so on. Very easy. More difficult was the second part, because second part was counterintuitive, I think, as it was instead of getting scores for the card, we were getting copies of the card. So if card 1 had 5 copies, then we get more of card 2, 3, and 4, and for each of those copies we would get more cards, and so on. So with input like this, the numbers of cards would rise very quickly. Yeah, very, very quickly. And the problem is that if we went from the beginning to the end, we would have to, because that was a first intuitive solution is, for card 1, get a function, get score. That function, we've got 5 matching numbers, so we get all those new copies of these cards, and then use the same function for those copies and for the cards we've had. And the last card returns 1, the recursive function thing. It was counterintuitive and long. Well, it was intuitive and long, so instead we went from the last element and we kept the score for each card. Last card, score 1, because it cannot generate any more scratch cards. Simple. This card, the maximum score is 2, because it's itself plus the score for card 6. This card, the score would be score for card 6 and card 5, which would be 3, plus this card, it's 4. If this card had only 2 matching numbers, it would be score for those 2 cards, which would be 6, plus this would be 7, and so on and so on. So you would keep the score for each of the cards. In this sense, as you can see, we're invoking one function for each card, then another function for this card, and one function for each card. We're not generating more cards with this solution, so we don't need to invoke the functions thousands or millions of times as we would have to do in recursive method. So that way we're having a very quick computation of the task. I know I'm a little bit chaotic but with explanation, and that's because English is my second language, but I hope and I'm pretty sure that day 4 and I'm slightly getting better. Another few days and my narration is gonna be much better. Anyways, I hope you guys enjoyed. Thanks for watching, and stay tuned for more videos. Subscribe for more content.